Okay, recording is started. Just so everybody's aware, please feel free to let me know if you don't want to be recorded. Um, we had a request to build a little dice game here, multiplayer dice game. It's a pretty simple dice game, but it's like the puzzle, probably going to surprise people how much goes into making even a simple dice game. A dice game that has very simple mechanics still requires a lot of code infrastructure behind it. I was a little bit concerned about doing this one just because there were some complaints on the last one we did about like the heavy, we did like one call that was heavy focused on server side networking and getting those two to talk to each other. And some people thought that was a bit dry and difficult to follow in the way that we did it. So um, this one is going to be largely more of that. A game like this, the proper way to do it is mostly on the server side, and then the clients all just kind of are busy displaying what the server is doing to each individual person. But you want the state of the game, whose turn is it, what's the current dice roll, how many points do people have, things like that, you want to be on the server. And you want the server in charge of those things for a lot of different reasons. Um, it makes it harder to cheat if somebody was trying to screw around with the screw around with the game. Then you know the server's the authority. Whatever they think they're doing on their computer doesn't actually matter. It also means that hi Miz, we're doing ship captain crew as requested, but it also means things like if a new person joins the scene, then the server can just be like, "Hey, new guy, this is the current state of the game." Otherwise, that new person would have to ask somebody at random, like, I see 5 people in this region. Who do I ask to tell me what they think the current state of the game is? And what they think the current state of the game is might be different than what somebody else thinks the current state of the game is, and so forth. And like if you lose connection, like if something, your internet goes down or your client crashes or something and you reconnect and it was your turn when you were playing the game, like you want to be able to rejoin the game and still have all of your points, still have the role that you were working on, things like that. And so by having all that stuff on the server means that if I crash out and come back, then the server just goes, "Oh, I remember you. This is what you had before. Welcome back. We're still doing that." So the the proper way to do this is on the server, which means it's going to be a lot of server scripting, which means it's going to be also a lot of networking back and forth between the server and the client. I'm going to try and make that as is a little bit more visual than it was before, and I've also done a little bit more preparation on it than I did before. So since we kind of talked about it a little bit on previous calls, I went ahead and just did the preliminary setup to get the networking and the server in place for this, so we don't have to do that on call. That's here. We can just talk about the game logic. And I thought we would try and explain a little bit what the server is doing, but visually. So I installed Dia, just an open source diagram modeling tool. Actually ordered a Wacom One, like beginner's tablet. It was like $50 because I'm hoping to be able to use it as like a digital whiteboard for future calls. So to make some of this like easier, and I can actually do some drawing with a stylus, and that can often be helpful for kind of diagramming out what it is that we're trying to build in code. It's something I've really missed having from back when I used to do teaching, is being able to put stuff on a whiteboard. So we'll see how that goes in the future, but that's not here yet. So for the moment, we are going to use Dia and see how that goes. And hopefully, if we can throw a little bit of visual stuff in here and a little bit of preparation ahead of time, hopefully it won't be quite so uh, dry and arduous to get through, and we can focus more on the game logic. But what we're doing in the server isn't going to make a lot of sense unless you understand kind of why we're doing it, because There's a little bit of extra complexity to the server, and that is there's one server script per region, no matter how many games are in that region. So that server script can't rely on the fact that it is just dealing with one game. So you might have, just make a little thing here. So we might have a game here, right? I have game one, and uh, that's in the region someplace. And then we have somewhere, we have a separate, this is going to be our server script right up here someplace. And so this is sitting here on one, the whole region has this one server script. And so down here on the clients, then you might have game one, right? So we can kind of just label this down here as clients games in a region, right? So we've got all of this. We might have game one, and then that works fine with the server script. But then suddenly you put down another game. You've got game two in the region, and now this game was busy trying to talk to the server, right? It's saying, hey, Simon rolled. Server goes, okay, this is what Simon rolled, sends that information back to the clients. This is going to be a two-way street here. So the server is going to be talking back to the clients as well. But as soon as you add, and that works fine with one game, but then you add a second game, and you suddenly have a problem because the server script, if it's not specifically designed to be aware of the fact that it might be talking to multiple different games and have some way to differentiate those games, then all you're going to do is you're going to get a bunch of crosstalk going on. So the when this game shows up and starts talking to the server, then if the server has no way to differentiate these guys, then this thinks that that both of these games are actually the same game, but there's different sets of people playing them. It's going to start showing up like people who joined game one are going to show up on game two as well, and somebody who scores on game two, that score is going to show up on game one, and you're going to be sitting there going, wait a minute, this game is me, Hinkley, and Simon. Why is Alper showing up on my scoreboard? He's not. He's way over there. He's on the other side of the region. Like he's playing a totally different game. And so these if you aren't designing the server script properly, then these games just kind of all morph and coalesce into one big blob. They're all just going to try and act like they're all the same game for every single one. The server is going to be if game one sends in an action, then the server script's going to send a response back both to game one and game two at the same time, and vice versa. If the game two sends in a message, then the server is going to be like, okay, I'm going to treat that as part of the game, and then send it back out to all the games in the region, and they're all going to be very confused, and the people playing them are all going to be very confused because it has no way to tell them apart. So the server script actually, what we're going to do with that is the server script has to be aware. So we have to come up here and we have to say, all right, so we have a server script, but within that server script, we actually need game one controller up here, and I picked a kind of a random shape for that there, so we'll just go with that. So we're gonna have to have a game one controller here and a game two controller here inside of the server script, so that these guys, when they want to talk, they're actually talking to this guy over here, right? But we have to remember that this is actually all one script. So the server script has to be able to do multiple games within itself and keep those straight so that it knows, all right, if game one messages me, I have a different game state for game one. And then if a game two messages me, I have a different game state for game two. And I have to be able to keep those separate. Otherwise, you are limited to having one copy of the game per region, and that's it. And if you try to add more, it doesn't. It not only doesn't work, it actually just messes the whole thing up. Adding the second game breaks the first game rather than the second game merely just not working at all. So when we're designing stuff to use server scripts in Sinespace, it's important that find some place to move that around. It's important that we think about, you know, it's a multi-user environment. So there's going to be multiple users in there. That's what makes us require the server script. But then there could also be, you know, multiple games running within the same region, each with their own set of players, but they all have to share the server script. So we have to design around this. This is something we didn't get to in the puzzle game, but the puzzle game actually had the same problem. That was one of the reasons it's not on GitHub yet, is I wanted to fix that off screen before I uploaded it, because it was going to require refactoring some of the code that we did to the server script. And I wanted to make sure that I wasn't uploading it in a way where it was going to have that problem if people put two or more puzzles into a region. So the code that we're starting with here actually is the refactored puzzle code that I did since the last call. And we'll be starting from there. So we'll be starting with it already aware of the idea that it's going to be talking to multiple puzzle games simultaneously. It's not a lot of extra work on the networking side, but it is a lot of extra work on the sort of state management and game management side of it. The difference that happened between the last one is, for the sake of limiting network traffic, then it now listens to two separate network channels instead of just listening for a master channel, which is in this case space sign ship captain crew. It's also listening for space sign ship captain crew dot whatever my global game ID is. And whenever you put a furniture item into a region, it gets assigned a permanent global ID for as long as that furniture item exists in that region. If you delete it and put a new one down, it's going to have a new ID. If you put two of them down, they have two different IDs, even if they're the same object. And so it's a unique identifier you can use on any object in the scene to tell it apart from other objects in the scene. So we just use that. I've got a variable here called, I've just made it simple for myself, my object.my global ID. That's what I'm going to use for my global ID. My object is the object that the script is running on. So this is the global ID of the scripting runtime in the scene. That's really what we care about. And at that point, I can use this as a unique identifier when I'm talking to the server. Anytime I send a message to the server, I'm sending my game ID along with it, so the server can tell me apart from every other game that might be in that space. And when the server wants to talk back to me, instead of shouting back on the global channel, it talks back to me on my own special subchannel that only I am listening to. And so each individual game has a callback channel that is unique to it. For the server script, everyone talks to the server script on the same channel. If you want to send a message to the server, you send a message to space sign ship captain crew, and we just include our game ID, and then the server takes care of the rest of that. So that part had, like I said, had to be retrofitted onto the puzzle game, because we didn't get that part because people were complaining about how tedious the server-side scripting was. So I did that off camera, but we're going to start with that here and see if we can just focus on the game logic of it. But hopefully this helps understand why we need a server script and why the server script is probably going to be more complicated than you expect and more complicated than what we did on the jigsaw puzzle last time, which I will get uploaded onto GitHub in the near future. I am working on that. All right, so we've got all that in place. And like I said, if anybody has any questions, feel free to just jump into voice or put it in text, and I will catch that at some point while I'm talking. will look over periodically at my other monitor and see if anybody's added any questions there or any comments. But let's go ahead and start thinking about how we build, like, the actual project for this is just 5 dice, right? So I grabbed this is a free dice asset off of the Unity asset store. But before we put this on GitHub, I'll probably ask Simon to make us a a die model that we know is, freely distributable and something that we don't have to worry about anybody's else's property on. But for this demo, I just went ahead and grabbed a free asset off of the asset store. It's pretty decent little assets, PBR dice, and this one's just 6-sided dice. But if you were going to make a game that needed other kinds of dice, they got D20s and D4s and all the usual stuff in there as well. But all we need for this one is D6s, so we've got that in here. We've got a server script running. That doesn't look like anything, obviously. It's just a script. And then the game itself is just a prefab with, the usual. It's room furniture items, got a virtual good on it. We've got a scripting runtime attached to it with the script we were looking at a moment ago. And it's got 5 dice that are 6-sided. And that's basically it. Like, that's most of the game here. We just stuck this in here, turned it into a prefab. We are going to want to build a UI for it. We don't currently have that. I've got a canvas in here, but there's no UI actually built on it yet. So that's going to be our scorecard at some point. But we will probably do that on a later call. I'll let you guys decide if you want to do that on call. Doing UI layout and stuff is at least more visual than doing scripting, and so it might be interesting for people to see how building a more complex UI is than the one we did for the puzzle game, which was super, super simple. This one will be a bit more complex. We can see what that would look like. This is an example from a YouTube channel that provides this as a free download for people to print out and play the game in real life if they want to. So we're not going to do exactly this because we don't need all of this, first of all, but we're going to be recreating this in Unity's UI. This is just an example to look at what we're kind of going for with this game. We don't need these 5 squares at the top, those where you would place the dice. We're not going to place the dice on our UI. The dice exist in the physical space, so we don't need those. But mainly we need the scorecard at the bottom, ship, captain, crew, what your cargo is. So we can see here that there's who's playing. This card supports up to 4 people playing, but there's no reason you can't have 10, 20, 30 people playing. There's no real reason that there has to be a limit. But that's something we need to think about when we're designing the UI for this is, do we want to have a maximum number of players that we support? Because that if we have an unlimited number of players that we support, then it increases the complexity of building the UI. So it's something we have to think about. We will have to think about already having a dynamic number of rows, because that's how many, the number of rows is how many rounds there are. So for every time a round is played, we have to add a new row to the UI. But if we have a unknown number of players, like if we just say, oh, there can be up to 4 players and that's it, then we can just design the UI with 4 columns and be done. But if we say, oh, can be any number of players, then now not only do we have to think about a dynamic number of rows being added to the UI, but we also think about a dynamic number of columns being added to the UI. So that's something we can deal with when we get to a UI portion. But that's kind of why the UI portion of that is going to be its own whole thing. Is it looks like a simple UI, and you can draw this in a few minutes on a piece of paper, but the logic of making it work in code is, again, probably going to be more complex than most people imagine it would be to build a UI like this. And it really depends on those limitations that you put in place for it. Do I have a fixed number of rounds? Do I have a fixed number of players? If not, if those things are variable, then the UI gets more complex. You can't just build it and be done with it. You have to build it to grow and shrink. So at some point we'll have to build this. This is just an example. But the actual logic of this game, when you're playing it with real dice, is pretty simple. You've got 5 dice, and your goal is to turn one die into a 6, one die into a 5, one die into a 4. That's your ship, your captain, and your crew. And then those don't actually give you any points. You just have to have those in order to have points. So if the real points comes from your cargo, and that's the remaining 2 dice. So the first 3 dice have to be ship captain and crew. If you don't get a 6 and you don't get a 5 and you don't get a 4 in that order, then you just don't score. You get a 0 for that round. If you can get a 6 and a 5 and a 4 in that order, and the order is important, then your score is the sum of whatever the remaining 2 dice are, the cargo that your ship is carrying. Sounds very simple in practice. Not a lot of game elements. There's no board, there's no pawns to move, there's nothing like that, no card decks. It's just 6 dice. Any random 6 dice will do. You get 3 rolls. You roll it. If you have a 5 and a 4, too bad. You have to have the 6 first. So you'd have to re-roll all 5 dice. If you roll a 6 and a 4, you can keep the 6, but not the 4, because you don't have the 5 in the middle. You've got to get a 6 and a 5 and a 4 in that order. You can roll all 3 at once. You could roll a 6 and a 5 and you can keep both at the same time, or you can roll 6, 5, and 4 and keep both all 3 at the same time. But you have to have them in the correct order before you can keep them. And if you get them in the correct order, then these 2 black boxes on the end become your points that go down into the round scorekeeping here. So very simple to learn with real dice. Going to take some work to get it to actually happen in code. So like usual, we're going to see how far we can get on part 1 today. There's going to be a part 2 and a part 3 and maybe a part 4. We'll see how far we get. It's going to be more than you expect. So let's just let's go back to our server script where most of our action is going to be, and think about what that means. So we have to be able to keep track of individual games. We know that. So what we're going to do is we're going to start off and we're just going to make ourselves a game table. We know we're going to have a bunch of them. And so we want to keep them all separate. So we're going to have a games table. Now, this games table isn't going to have anything in it by default because we're going to add stuff to it at runtime. But let's think about what that is going to look like. So for any given game, let's say I've got another game under here. What do I need to know about this game in order for it to be something that the clients can parse and understand and play with? Well, there's some basic stuff. We need to know whose turn it is. That's going to be pretty important. There's 4 people playing. We can't let them all play at once, so we have to decide, oh, it's your turn. You're the one that gets to roll the dice right now, right? So we're going to need a turn. By default, it's going to be nobody's turn if the game's not running. What else are we going to need to know about it? Well, we're going to need to know what the current roll is, right? So we might have a table here that says dice, and this is going to hold whatever the current value of all of the dice is. So this might be like 2, 5, 4, 1, 3. We've got 5 dice, so we would expect there to be 5 integers in our table here telling us what the dice actually are. What else do we need? Well, we're probably going to want to keep track of what everyone's scores are. That's going to be important. So each game is probably going to need its own scores table, right? That scores table is going to be more complicated because it depends on whether we want to track what the scores for each round are versus what we want to track for each, just what the total score is. We probably want to do both, right? If we look at our scorecard here, we can see that we have a per round score for each player, but at the bottom we also have whatever their current totals are. So we probably want both of those. We could just keep track of the rounds and then on the client side do the addition, add up all the rounds and show them here. But it can actually be useful for us to go ahead and store the current aggregate score for each player as well, because that's what's going to determine like who wins later. And we can save ourselves some work if we just keep track of the aggregate scores as we go. So this is going to have a number of scores in it that's equivalent to whoever's playing. And so that's then we're like, okay, well, how do I know how many people's playing? Well, I got to keep track of that somewhere too. So this is going to have a players list. That players list is going to at least hold everyone's avatar ID, their account ID. That's their unique identifier, right? So there's going to be some numbers in here. If there's 3 people playing, we expect to see 3 numbers in here representing the unique IDs of the people who are actually playing this game. And then we would also expect that there would be some score associated with each of those. And there's a couple of ways that we could arrange this, depending on how we want to structure the data. So scores could be its own separate table, separate from players. And if we want to know who a score belongs to, we can cross-reference it with the players table, figure out who that belongs to as well. But we might decide, this would actually be a lot easier if everything that we wanted to know about a specific player in the game was actually all just part of that player, right? So something we might do here is, instead of structuring the data like this, because we would need more than this, right? We would also need to know what the scores for each round were, right? So if we were going to structure it this way, then we'd have to say, well, each of these is a subtable because these players are going to have played multiple rounds. So maybe to get 8, this player got a 2, a 4, and another 2. And maybe this player, that would be the equivalent of getting 1 point on round 1, 4 points on round 2, and 2 points on round 3, right? So we'd have to keep track of all of that when we went to go put it on the UI. There's we have to have the same thing for all of these. And so, and as we go along, we're probably going to find there's other information about players that we want to store. Something that might be useful, which I think we touched on a little bit with the puzzle game before, is that servers aren't very good with names. If we just keep track of IDs, then we run into a problem of this person was playing, they're not here anymore. How do I get their name to put on the scorecard? And so if they're not in the scene anymore, then I have no way to go, oh, well, let me look up this user's ID and then I can get their name from it. If they're actively in the scene right now, if they're connected, then I can say, oh, well, look up who avatar 555 is. That's going to give me an S avatar object back, right? So if we go look at our scripting API reference here, right? So I can go to scene, and this is space.scene, and so there's a bunch of functions on here, some of which are get avatar, right? I can say get an avatar by a name or get an avatar by their ID, and I'm going to get back an S avatar object, and an S avatar object has a bunch of stuff on it, one of which is, username, display name, title, things like that, which is what we want. But that only works if they're currently in the scene. And so if you want to be able to kind of keep a scoreboard consistent and be like, okay, I want to be able to show your name when you're not here, then you need to remember that name. And so typically what you would do is when they join the game, you say, hey, this user with this ID has joined the game. This is their name. This is how they want to be presented on the scoreboard, whether that's their username, their display name, whatever. You could ask them to enter a name of their own, something entirely different to put on the scoreboard if you want. But however they've chosen to appear on the scoreboard, then that all gets sent at the same time. This ID, this name, whatever else is relevant about this person, and then you need to remember that. And that way, when you send it to other clients, you be like, hey guys, here's the current scoreboard. You can show both a name and a score without having to worry about whether they're currently in the scene or not. So that's something else we would have to store here, right? So, I mean, we could have a player names table here, or we could say this is Josh, this is Simon, right? This is Hinckley, not real user IDs, obviously. Um, so this starts to get pretty messy. It would actually be a lot easier if we just thought of these as objects instead of as arrays. So Lua is kind of object oriented. You can't declare a class like you could in like C# or something, and then be like make copies of this class. But you can build repeatable objects with the same structure and pretend they're classes. If you know that every time I build one of these, it's going to have the same structure, then other code can treat those objects as unique classes, even when they're not. So, and that may not make a lot of sense to people who aren't already engineers, but I'll kind of show you what I mean. For people who are engineers, that probably makes a lot more sense. But what we're going to do is just we're going to restructure this. So instead of having all of these individual tables, we're going to have a players table. And then within that players table, we're going to say, okay, well, player 1 is here, and player 2 is here, and player 3 is here, and each of those contain some information of everything we care about that player. So this one's ID is 555, this one's ID is 666, this one's ID is 777. Name is going to be Josh, name is going to be Simon, and name here is going to be Hinckley. Right? So now we no longer need these two tables. So we got that. But now we also need to say, okay, well, we probably also need to know what score is here. Oh, that's the wrong score. It should be 8 and 12. Simon's winning, obviously. And then score is 3 here. So that means we no longer need this table. And then we say, okay, well, for you, the past rounds that you got to get to 8 are going to be like 2, 4, 2, and the rounds that you got a nothing, but then you came back with a vengeance. And that's how you got 12. And then for Hinckley, Hinckley's just like slow and steady. Just gets a 1 every round. That's how you end up with 3. And so this is what our data looks like now. This is what the game has to remember about every person who's playing. And we might add more to this later, but this is kind of the basics that it needs to understand about each player within a game. And you might have multiple games, so we're going to have a way to find the game that we care about. There's a couple of ways you can do that, some pros and cons. One is I can add an ID here, and this is, game 3. This will be game 3 global ID. And then if I want to find information about game 3, what its current state is, I would need to know that game 3 is the first item in this table. And to do that, I'd have to look at the table every time and say, okay, if I've got a bunch of games in here, like there might be 3 games being played all at the same time, right? So this might be game 1's global ID and game 2's global ID and game 3's global ID, and they have different players and different scores, imagine. And if I get a message from game 2 that says, somebody rolled, you need to roll the dice and you need to put new dice in here, or somebody's score has changed, I have to figure out that this global ID is the second item in this games table. And that can get tedious, and it's also inefficient because I'd have to do like a search through the table every time. I'd have to go start a for loop, check the first one, does this global ID match? Nope. Check the second one, does this global ID match? Yeah, it does. I'll do that. I don't know how many games might be being played in here, but if you had 10 games, 20 games being played in the same region, then I don't want to have to search through all of those every single time. So probably what I would do instead is just treat these as like associative arrays, where instead of indexed arrays means that it's, you know, one, two, three, four, five, no gaps. There's something at the first position, something at the second position, something at the third position, and so on. And an indexed array means that everything in that array has a tag, and I can just reference it by that tag instead of its position, right? So the difference there is instead of saying games to, you know, dot turn, move that up, I would say games global ID dot turn equals 1, and I don't ever have to search to find it because I always know exactly where it is. We can store the global ID in here anyway as well if we wanted to, but probably just excess data in that case if we're not actually going to use that for any sort of searching or cataloging. But we'll come more to that as we start putting code in here. For right now, it's just what is the structure of this data going to look like? I need to kind of nail this down so that when I'm actually manipulating the game, I have a reference for what all of the data looks like and how I'm going to manipulate it. That's not really, I mean, I could leave this code here, but then it would just think it's got a bunch of games running that don't actually exist. So I need to take this code out and put this table back to being empty to start off with, because it will get built up as we play games on it. If I can remember how to do a block, a block quote in Lua. It's something weird. I am just going to comment this whole thing out, just so we have it here as a reference material. Oh, I have insert on, no wonder. Okay, so just so we have this here as reference for when we're building the game, this is what we want our game structure to look like. So we'll put a comment here. It's just data structure for games table. And it's useful to do this kind of stuff even for yourself, even when you're not showing somebody this stuff. Even if you don't think you're ever going to give this code to anybody, it's still useful for you to kind of document your own code, because you might come back to this 6 months later and go, I have no idea what I did 6 months ago. That happens to pretty much everyone who does any kind of coding. It's like I wrote something, and then I went on to write something else and something else and something else. And there's no way I'm going to remember all the specific details of something I did 6 months ago or 6 years ago or whatever. So it's useful to get into the habit of documenting what you expect these data structures to look like, and that will make it a lot easier for you to come back and work on it again later and understand what your own code was doing before. But basically, whenever a new user joins the scene now, if I log into a scene and there's already 5 people there and they're already playing, then, and I need to know what's going on, I need to be caught up on what the current state of the game is, then all the server script has to do is send me this whole table. Just be like, hey, you're new here. Here you go. This is everything to know about this game. It's all encompassed in this table. You can then arrange the dice on, you know, if this is what the dice are supposed to be, then when we come over here, then what I should see on the top of these dice when I join the scene should go, oh, well, I'm supposed to be a 2, so I'll rotate my 2 up. And I'm supposed to be a 5, so I'll rotate myself so that the 5 is pointing up, right? And then take all of this information, put it onto the scores, right? It's one of the things we'll want to think about the UI is you may want the scores to be visible to people who aren't playing, because it's more fun to watch a game that way. Like maybe you don't want to play, but maybe you want to watch other people play. So we might need a way for people to observe the game, see the scores. So we might actually want to think about putting the scores on like a world space canvas instead of a screen space canvas, and have it be on like a physical object in the scene so that I can watch the physical dice roll. I can see the people standing around it playing, and then I can see their score on the board behind them, right? I don't have to actually be playing for that UI to come up like we did with the puzzle game. You didn't see the UI until you actually decided you wanted to play. And this for a game like this, it's probably more fun if you can see that whether you're playing or not. So that's something we'll look at later. That's all part of the client side. It's like I said, this is mostly going to be like, how do I get all the game logic on the server code to work? And then the clients are all just showing whatever the current state of the server is. That's really their whole job is just to be like, well, the server says these are the dice, and the server says it's this guy's turn. The server says that these are the points currently on the board. I'm just going to make sure that everyone can see that. I'm just going to show that to every user who logs in, make sure that they can see the same thing as every other user. And so the client side code is really just taking data from the server and then adjusting all the visual elements to match. And that's most of the client side code, right? There's going to be a little bit of code where I want to say like, oh, they need to be able to roll, right? They need to be able to tell the server, hey, I want to roll these dice. So we'll probably need to make the dice clickable, right? And then when you click on that, that'll just send a message to the server saying, hey, Josh wants to roll his dice. And the server will be like, well, it's Josh is playing this game and it is Josh's turn. So yeah, we'll roll the dice. I'll randomize what the five dice are and then tell all the clients, hey, this is what the dice look like now, and everybody will update accordingly. And ideally you'd want to do some like fun stuff. Like we can quick and dirty, we'll start off with just like, oh, I'll just rotate these dice so that the right side is up and call it a day. But then once you've got the game mechanics worked out, you're probably going to want to think about ways to make it more fun, right? You're probably going to want some sound effects. We'll find some dice rolling sound effects. So anytime a dice roll, then everybody can hear them roll and not just see them roll. And even something like that, you kind of got to think about it a little bit more than you probably imagine, because I have to say, okay, well, I probably don't want to play the same sound effect if I'm rolling one die versus five die, right? That would be weird to the user if I click roll and only one die changes, but in my ears, I'm hearing five dice roll, right? Like a whole bunch of dice hitting the table at once. And so you're probably going to want to find multiple dice sounds. What does it sound like? You don't need necessarily do all of them, but you might want to have a sound for rolling one die, a sound for rolling two or three die, and a sound for rolling four or five die. And so it kind of what you see visually kind of matches that audio experience. That's something that you're going to want to think about on the client side. The client side isn't really doing anything. Again, it's just taking information from the server. The server is going to be like, hey, I rolled five dice. This is what they are now. All the state stuff is on the server. And the client side is just about showing what that state is, but making it fun. So we might decide, oh, well, if the server says the dice get rolled, rather than just rotating the dice and be instantly and being done, maybe I make the dice like jump up and spin around a little bit and then fall back down. And when I fall back down, I want to make sure that they're always got the right side up, because we've predetermined the dice roll rather than using physics to determine what the dice roll is. So you might want to play an animation, might want to play some particle effects, might want to play some sound effects, things like that on different features of the game. If somebody is rolling and they, get their ship, then you could have some fun with that instead of just saying, oh, they got their ship. Okay, they met the requirements. Let's move on. You can make a big deal out of it, right? You want it to be more fun. So you could play like a sound effect for getting the ship, for example. You could make like something silly, like grab the sounds of like, ship rigging, straining in the wind, that creaking, groaning sound as the ship gets under sail. You could have, like an actual ship model, like appear and like sail across the dice and then disappear off the other side, right? Just kind of celebrate the fact that you successfully got your ship, for this turn. And you can do the same thing for the captain and the crew. When you get your captain, then maybe you get, maybe you play some silly sound effect like, back to work, all hands on deck. And, when you get your crew, then they can all be like, aye, aye, sir. You can have as much fun with it as you want to, but this is all just dressing on the game mechanics. Once you get the whole thing put together, it really helps to sell the game experience. You can have a game that works flawlessly, all the mechanics are in place, but is still super boring because there's nothing to look at, there's nothing to listen to. There's no fanfare, there's no celebration, and it feels dull, even though technically it works. And so once you get past the technically it works part, that's when you're like, all right, now how do we make this interesting? How do we make this silly? How do we make this fun? So that's kind of unfortunately one of the last things that you do, because you can't hook all of that stuff up until all of the proper game logic is in place. I can't put a dice rolling sound in here until I can actually roll the dice, right? I can't put a ship sound effect in here until I actually have a way to determine whether the ship was successfully achieved or not, things like that. And so that kind of like adding flash to it is going to be like the very last thing. We might try to break it up a little bit, and as we sort of get game mechanics in incrementally, then maybe we'll take a break from the code and be like, okay, we can roll the dice now. So let's stop and go look for a dice sound effect or something and see how we get that into the game, just to kind of break up the scripting a little bit. But it still has to come after each bit is scripted. You can sit down and just kind of plan all this stuff out and be like, oh, I know I'm going to need all these side effects, so I'm going to go get all these sound effects and put them in a big pile in a folder someplace and know that they're there ahead of time, which is something I might do off camera. But there's no way to hook them up until the rest of the code is done. So it's just that would be just kind of a planning exercise more than anything. All right. So there's a lot of preliminary stuff in here. You're building the game. You have to understand the architecture, server client. You have to understand there's going to be multiple games that have to rely on the same server. Okay. You have to understand what physical elements need to go into there. We're going to need some dice and a scoreboard. You have to understand what the rules of the game are, because the rules dictate what the data structure looks like, and it's going to dictate how the game logic goes. Can I only do stuff on my turn? Is there some stuff I can do on my turn, but some stuff I can't do on when it's not my turn? Every game is different, and every game is going to have a different logic set. So you got to sit down, really learn the game before you can actually put it into practice. Luckily, this one's very simple. Simon sent me a YouTube video. It's like 3 minutes long. There's not a lot to learn about how the game actually works. So that part was simple, but now we have to put it actually into practice. And I realize we've spent most of this call here talking and explaining what we're going to be doing. But that's an important part of getting the game off the ground. But let's see if we can actually get some code written in the next half hour here or so, because I don't want to keep everybody too long. So what are we going to do with that? Well, the server has to know when somebody joins a game. That's kind of the most basic part. Server says, somebody joined. We talked a little bit ago about catching people up. That's what this event is for. If a user logs into the scene, the game loads for them, that script comes online on their computer, their client-side script comes online. It's going to shout out to the server and be like, hey, I'm here, I'm ready. I'm up and running. Give me whatever, give me your best. Give me whatever you got. And so in that case, we just need to send back to them what I mentioned earlier, which was all of the information we have about that game and let them figure out how they're going to show it on screen, right? So what we're going to do is we're just going to insert into our outgoing responses. That's just our response table. We're just going to insert a game state message. We're just going to say, hey client who's just checking in. And what is the current state of the game? Well, it is going to be our games table at whatever our game ID is. This might be nothing, right? If nobody's playing that game, it might be nil. It's okay. It's okay to send back a nil. That just means that's just telling that client, hey, I heard you. I'm responding to you just to let you know nothing's happening with that game. But that game is going to be expecting a response of some kind. So even if we send back a nil state, that's fine. It's still a response. It still knows the server heard it, responded back, and it knows for sure now that it has the accurate game state, even if it's just nothing's going on right now. There's no game being played. And then we have to say, okay, well, what happens when a player joins a game? All right. Well, we might say that it's okay for a player. We we have to decide whether there's an explicit start to the game, right? Do players get to join a game and then that's what starts the game? Or do we press like a start button and that's what gets the game started and then players can join it? Uh, Generally, the easiest thing to do here is just to say the first person who joins it, the game starts, right? That's the most obvious way to do it. What we can do here is we can say also that rather than sending back a nil state for a game, saying, oh, there's nothing going on here, we could actually use this opportunity to build the initial game state. So we could come in here and we could say, all right, client started. Then let's see if it's the first time that this particular game has ever logged in. Because the way our platform works, right, is like a region is off when there's nobody in it. It's not running at all. And the first time a user joins a previously shut down region, that region's going to start up, and then all of the scripts on that user's computer are going to start up, and that's going to start up any associated server scripts that are needed by that content. And so when you go into a previously empty region, this is all going to be empty. There's going to be nothing in here. Even if you were in this region before and you had played games in here before, if you left and nobody else was in here, it shut down. This is all gone. And when you come back, this starts back at nothing. And so we always have to check for that case of this is the first time. You're the first person in this region. We're starting everything back up from scratch. I got to rebuild. And so we can come in here and we can say like, well, if game is nil, means I've never heard of this game before. Either you're just starting up a region again, or maybe you just placed down a new copy of this game that wasn't in the region before, even though the region was running, it didn't have a game in it until you put this down. Either way, I've got a brand new game on my hands that I've never heard of, at least for this session. And so I'm going to say, okay, new game, let's build the state for it, right? And so that's what I'm going to do is I'm just say, well, if it was nil, we need to make it not nil. What is not nil? Well, we already decided what that data structure looks like. That's this up here. So we're going to go ahead and just build what the structure of this looks like. Now, for a brand new game, nobody's playing it, right? So there's no players. Players table is empty, and we can just decide that like, okay, well, for a brand new game, all the dice start off as 1. If nobody's playing the game, it loads, boom, the dice are all snake eyes until a game starts and somebody rolls it for the first time. There's nobody's turn, so that's just nothing. And this, we can save this if we want to. Might be useful later. Wrong bracket there. Right. So we're saying, okay, there was no game. I've never heard of this game before, but with this particular game ID. So we're going to start by building a game state for it, and then that's only going to run once, only in the case that it's the first time we've ever heard of this game. And then after that, everybody is going to just get sent whatever the current game state is. For the first person, it's going to be this because you just asked for this game state. It didn't have one, so we made a new one, and you're going to get that new one sent to you. By doing that, that means that over here on player joined, we can assume the game state already exists. I don't have to over here say, oh, well, if game does not equal nil, because that shouldn't be possible. It shouldn't be possible that I ever get a player joined event before the script has come online in the first place. And if the script is online, we already built the game state, so we can just assume that it's there. So we can say, okay, well, player joined. We know which game they joined because every message that comes in has the game ID associated with it. Likewise, every message that comes in has the player ID associated with it. So we know who wants to join a game and which game they want to join. We just have to make sure we put it in the right spot. So very, very simply, we can just be like, all right, um, we're not going to do any checks here for whether a game has reached maximum capacity. That might be something we decide to do later, but let's just keep it simple for right now. So I'm going to be like, okay, well, I need to put you in my players table then if you're new to the game. So I'm going to say insert into the games table for this particular game that you want to join. And specifically, I want to insert you into the players table of that game. So what do I want to insert? Well, we decided what that was going to be up here before, right? So we're going to insert ID. So that's just going to be player. That always comes along for free. We want name. So we're going to assume that this packet that sent us a join request also included the player's name. So we'll just assume that data.playerName is a thing. And then they need a score and rounds, right? So we can say, well, if you just joined, your score is 0. You don't have one yet. That's pretty obvious. Rounds is a little trickier because if we allow them to join mid-game, then there might have already been some rounds played. And so we would need to add in some zeros for them for any rounds that they missed. Probably puts them at a huge disadvantage, but not necessarily, if you missed 1 or 2 rounds, doesn't mean you're out. So we would have to, for example, keep track of how many rounds have been played. So that might be something that we want to add into our game structure here. So we might say, okay, in addition to keeping track of whose turn it is, we're going to keep track of which round we're on. And if we're not playing, then there is no round. We're not around anything. And if we do that, then what we can do down here is we can say, well, local round scores, make a new round scores table. And then we are going to loop from 1 to whatever the current game round is, right? By 1. And gotta get the syntax right. Now the thing with that is, then I can do table insert round scores 0. So for every round up to the current one that we're in, add a 0 to this table. So if we're on round 3 when I join, then I'm going to expect to have 2 zeros, not 3 zeros, because I missed 2 rounds, but we're still on the 3rd round. And so if I'm joining at the end, which means if round 3 is still going, my turn hasn't happened yet. So I'm going to want to see this if I'm on round 3 of the game. So rather than going up to game.round, we actually want to do round -1, right? So, and if we wanted to, the logic comes out the same, but if you want to say, game.round is greater than 1, right, then we need to add in past rounds. So we run our little loop here. Not following you on that question, Louis. So there are 6 numbers for each to randomly choose. We don't need, we have a dice table, that's what this is, that shows what the current value of the dice is. There's 5 numbers for 5 dice, and each of these numbers can range between 1 and 6. So that's all we should need for keeping track of dice. We don't need to keep track of the dice on a per player basis, because it doesn't matter what your rolls were in past rounds. For the purposes of the dice, all that matters is what the dice are right now for the current player's turn. And so that's not a player-specific data, that is game-specific data, and we only need to store it once, not for each individual player, because it's only one person can take their turn at a time, so we don't need if I've got 5 people playing, I don't need to keep track of 5 sets of dice because they can't all be doing their turn at the same time. They can't all be rolling their turn at the same time. We take turns. If it's my turn, I'm using the 5 dice. There's only 5. And just like in a real game, if your turn is after mine, I say, okay, I'm done with my turn. Josh is done. I pass it to Louis. I'm actually passing you those actual dice, right? You're using the same dice that I was using. So there's no reason to keep track of past rolls. Past rolls don't have any purpose to the game. All we care about is what score you got on those past turns. And that's what we're doing here is we're just saying, if you're joining late to a game, you didn't get a score on past rounds. And so we're just putting in some extra zeros there. And we can say round scores here is whatever. If you're joining on the first round, this will just be an empty table. That's fine. That's great. That's what we want there. But the dice are just for the current player's turn, and that's it. Does that answer your question? Yeah, we're just storing what score we're storing your aggregate score for every round. If you play 3 rounds, then score is going to be the sum total of what you got on all 3 of the previous rounds. But then just because, and that's all we really need to play the game is your aggregate score. We could just keep track of that. And when you get done with your turn, we just add whatever your score for this turn is onto your aggregate score and move on. And that would be enough to let us decide who wins at the end of the game. We get to the end of the game and I can be like, oh, there's 4 people playing and this person has the highest aggregate score. They won. That's it. But because we want to be able to show a proper scoreboard in the game that looks like this, right? Then we're keeping historical round data here just because it makes the scorecard UI more interesting, and you can see how you got to your aggregate score from playing the past number of rounds. You can see how well people did going up, and this makes the game more interesting, both for people who are playing it and people who are observing it, even if it doesn't feel like it has a lot of value. It could have some value to the player in terms of their decision making, even though it doesn't affect the outcome of the game necessarily. So, for example, if you were playing this like with betting, like you're like, oh, I'm gonna put some chips on this, and who gets the chips, it's a winner take all, depends on who has the highest cargo score for each round. Then, it could be useful for you to see what scores people got on the past rounds, because then you can say, oh, well, that person got a 2 and that person got an 8 and that person got a 10. Then that means I know that I need to beat a 10 to take all the money. And that way, when I'm looking at my score, what my current cargo, I can see like, oh, I've got a 9. That's not enough. I need to re-roll. Or you can say, oh, I've got 11. That's enough. I can just stop. I don't need to roll more. I can just, and risk getting a lower score. I've got what I need already to take the pot. And so it can influence the game's how players make decisions about, because they're how they play, because you get 3 rolls per turn and you aren't required to use all of those rolls. You might be perfectly happy with the first one, or you might use all 3 of them and still get 0. And so the information that you can give the user, you can give the player about, historical information like that can matter to their decision making process, but it wouldn't matter to determining the outcome of the winner. Like, you still know who has the highest score. That's that. But in this case, we're keeping both. We're keeping your aggregate score and we're keeping your score from each individual round as you go down, so that we can fill in each of these rows, but then also the total at the bottom here when we get around to building the score UI. So we've got that in there. Now that's it. We've added them to the game state, but then now that we've said, okay, we've got a new player, we've figured out what their past round score should be, if any. They're going to start at 0 because they're brand new. And we know who they are. We've added them to the players table, so we know now. We have to now tell everybody, hey, there's new players, right? So we're just going to insert into our everyone table here. We'll just say the game players have changed somehow. So we're going to say, and then we're just going to send them players equals games game dot players, and that way they know, oh, there's a new player. I better update my UI to show this new player their name, what their current score is, and so forth. Everything they need to update their score UIs. The way this response in everyone, this is just kind of a standard template for server scripts that I've started using, and it's just means that if I put something in the response table, it automatically goes back to the person who asked me the question. Whoever messaged me, I'm going to message them back directly. If it's something that everyone needs to know about, then I can stick it in the everyone table, and that means it will go out to all clients. And now I've set this particular script up so that when I say everyone, I actually mean everyone who's playing that particular copy of the game. So like you can see down here, I say like, okay, if the everyone table has something in it, and I have a game ID, which I should, all messages coming in should have a game ID, then instead of sending it out on the main broadcast channel, that message is going to go out on that game's specific network channel. And that's true for sending individual responses too. Individual responses are useful for things like client startup. Hey, I'm new here. I just joined. Catch me up. Well, I don't need to catch everyone up. I just need to catch up to the new guy. Everyone else already knows what's going on. So that would just be an individual response. But if the scores change, every copy of that particular game needs to know that those scores changed. So I'm dropping that one in my everyone table, and then that's going to go out. The reason I have these set up as tables is because it allows me to send out multiple responses in a single network packet. So I can cut down on the number of network messages going out. If I need to send you both what the current dice are and the new players at the same time, I can send those at the same time in one message and not have to send it as two separate messages, which gets to be important later for optimization. If there's a lot of people playing, if there's a lot of games in the region, if there's a lot of activity, especially if people are playing quickly and there's a lot of stuff happening at once, then the game might appear to slow down if the server script has to start throttling its outgoing messages because it's sending too many. There's a limit. Both client side and server side, we have a limit of scripts can send, I think on the public grid, it's 20 messages per second. And so that sounds like a lot. 20 messages per second, there's a lot going on here. But that actually can be overwhelmed pretty quickly in a busy region if there's a bunch of games playing at once. So this script has a bunch of stuff built in to where if I start sending out too many messages, I start taking little breaks and going, okay, I'm going to wait a second before I send out the next message. And on the client side, that would be perceived as a little bit of lag. Like I clicked roll, and instead of the dice rolling immediately, like maybe a half a second goes by and then the dice roll. I'm like, oh, that was a little bit of weird lag for some reason. And so you want to avoid that as much as possible. And so bundling messages together helps to avoid that where possible. You can send multiple new bits of information distinctly out at once and avoid overloading the queue, basically. Lots of stuff you got to think about. Like that's a lot of stuff that I just kind of set up beforehand, but that's why these tables exist and why it works for me to, in this particular case, to just drop a message that I want into this table and send it going out. If you were writing your own server script from scratch, the actual mechanism that actually sends the messages out is this space.send message to client scripts that sends it to a specific person, or space.send message to all client scripts sends it to everyone in the region, and they can deal with it. So it would be, eventually this all gets down to these two messages here that are part of our API. But I've got a lot of extra wrapping around it for optimization reasons. Okay, so we've got player joined. We would have to deal with what happens when the player leaves, which is an interesting question because, what if that player leaves and then comes back and wants to rejoin the game? We could just, when they leave, go, oh, that's it. We're taking everything out. We're deleting all your stuff. You're just not part of this game anymore. We forget everything about you that exists. Or we can say, like, all right, you're gone, but it was still important to know that you were here and were playing. This actually saves us a little bit of effort in one way, but costs us a little bit more in another, because if I say, oh, if you leave, you're just gone. We cut you out. We forget you ever played. You're just out of here. Then when I send that update to client scripts, they not only have to look for players who are new and add more UI elements, but they also have to look for players who are gone and remove a bunch of UI elements. So doing that is simpler on the server side, but actually makes the client side more complicated. And actually, even it's not even as desirable, because you want to know that this person was here and got these scores, even if they're going to get zeros from now on. They were here. They were part of the game. And so when we take a player out, rather than deleting them, what we're going to do is we're going to add a little bit of data here that says, are they currently playing? They were playing. Are they currently playing? For a new player who joins, that's true. They just joined. So when we set them up, we're going to say, yeah, they're playing. But then when they leave the game, rather than taking them out of the table, what we're going to do is we're going to, let's see, loop through our table. Games, game, dot players. We got to find this guy first. And we have to say if games, a particular game in the games table, we look at their players and we look at this particular player, and the ID matches the player who says they want to leave, then all we're going to do here is set their dot playing to false. And we found them, so we don't need to look at anything past that, so we're going to break this loop. And then again, we're going to tell everyone, hey, something about players has changed. Here's the updated list. And so on the client side, rather than having to worry about like removing a bunch of UI elements and deleting stuff and losing that historical data, if I just say, oh, this guy isn't actually playing anymore, then the UI can just do something simple like gray their name out or put a red X over their name or something, and just be like, yeah, this guy was here. This is the scores he got before, but he doesn't matter anymore. He's out. And so that makes it real simple and all we have to do, then all we have to worry about is when a player's playing, like if I finish playing, I'm like, I'm done. I got my score, send it to the next guy's turn. I just have to make sure that if the next guy isn't playing, I skip him and I just keep looking for the next person who is playing, who is still in the game, and make it their turn instead, which we'll get to. We've got about 10 minutes left here before we kind of run out of the end of our period here. There's what should we do next? Well, we can make sure that, for example, if we come over here in the client, these messages that come back to the client have to be handled. So we would have to have corresponding events over here on the server script. We can be like, okay, well, if I get a game state message, total game state update should only happen the first time I join a scene, right? So I'm going to have to process that. I'm expecting that anytime something about the players changes, that I'm going to get a game players message. Something about players changed. Someone joined, someone left, someone scored, etc. There could be a lot of reasons that I'm getting this. So now I need to update my UI to show this new data, right? That's going to be a message that I get in. So that connects to these messages that we're expecting to send out over here. We decided we were going to send out a game state message. We decided we were going to send out a game players message. We need to make sure that the client side is looking for those, and then we'll figure out what to do with them. So over here on the client side, we're probably going to want to keep a mirror of what the server is doing. So I'm probably going to want to keep a game state variable. We'll probably start off as nil when the client starts up. And then whenever the server says, hey, here's a total game state update, you're new, you've never, you've got to catch up everything, then all I'm going to do is take whatever the server says the game's current state is, and I'm gonna save that because that's going to be useful for me. And that syncs me up with the server. And what is the game state? The game state is this. It's going to be this entire table is going to be what I'm sending to the client. So the client's going to be like, oh, thanks. That's useful. I'm going to have that. If just game players get updated, then I'm just going to update just the players. And that's going to be make what I know about the players match what the server says has changed about the player. So I'm just updating a small part of that. And then I'll probably have a function here, update scorecard, right? Something like that, that takes all the information in game state dot players and puts it on the UI somewhere for people to see, right? So whenever I get game players updated from the server, then I'm going to call my update scorecard function, and that's going to handle everything it takes to put that onto the UI and build the UI accordingly. We're going to want to do something similar over here. It's going to be more complicated though. Like, okay, everything changed, so everything includes the players, so that's one of the things that I need to update. But there's more than that, right? So I'm probably going to want to have, update dice function, because part of what comes over from the server is what I've got 5 dice, and I get told, here are 5 dice. This is what their current values are. That's part of the server state, right? So in addition to updating the scorecard, I'm probably going to want to update the dice with whatever that new information that comes in as well. So any information that comes in from the player, there might be other stuff. The scorecard is probably also going to handle like showing whose turn and what the round is somewhere on the scorecard. That's going to probably be part of the information, right? If we look at an example scorecard, then we could do something like, I'm just going to grab this so I can draw on it. So we can do something on our UI where we're like, okay, I need to show which round it is. Well, it's pretty obvious that the current round is going to be the most recent one on the bottom, right? But we might want to show that visually somehow, some way, right? So we might want to put like an arrow on the UI. It's like, hey, this is the current round. And if we want to show whose turn it is, right, we're probably going to want to like have something that highlights, oh, it's player two's turn, right? So let's put like a big green box around their name, or maybe even around their whole row or their whole column here, to indicate that that's currently that player's turn, right? So information beyond just the scorecard is going to be important here. So like turn, round, things like that. Those technically all go onto the scorecard. So that's something that maybe this update scorecard function will just handle by itself. All of that information will go up there. So this will handle stuff that's on the UI, and this will handle what little like physical objects exist within the space, which is just the dice themselves. And then if the player were to roll, for example, then we're probably going to get an event like game dice in here, right? Where we're just saying, oh, the player rolled. This is their new roll for whoever's current turn it is. So we're going to update the dice, and that's all we're going to update because that's the only thing that changed. Nobody's score has changed yet because they're still in the rolling phase. And so kind of all 3 of these are most of what we need to get the game state back from the server. Something about a player changed. Either they joined, they left, their score changed, whatever. That's information we're going to need to know. What the dice currently look like, that might have changed because somebody rolled. We need to know that. And if we're just joining the scene, brand new, then we need to know all of that at once so we can get everything updated at once to match what other people in the scene are currently seeing. So this is going to update the dice models in the scene to reflect the current values of game state dot dice, right? And these are where, like, um, you know, in the future, add sound effects, add particles, add animations, right? Whenever we got that update message from the server that said, hey, the dice have changed, then this is where we would add the fun stuff. All right, let's play our dice rolling sound. Let's make those dice spin for a couple seconds before they come with the right number up. You know, maybe when they hit the ground, we have like a thump and like a puff of like dust comes out from underneath them or something with particle effects. Like you can really like play with it and make it fun that way. All right, that's about all we're going to get to today. And I realize it feels like we didn't get very far, but that's kind of how this goes. You have to get all this preliminary stuff in front. You have to decide what the game rules are, how the game structure works, what the game data is, get all the networking set up so that the client and the server can talk to each other, which I mostly did off screen. Yeah, we can make it so you could choose the color of the dice. That would be a client side thing. You could, on the scorecard someplace, you could add a button, right? So we could just decide somewhere on the scorecard is like a settings button in the corner someplace. And if the user clicks that, we can give them some choices of like, oh, I really like red die or I really like blue die. And it would just show up for them, right? You could choose to make that a game state feature where like the owner of the game gets to decide what color the dice are, and like this game's just red. That's just all it is. Everybody sees red dice. This game's blue. Everybody sees blue dice. Or you can give the user the option to customize how it appears to them, and everyone else can pick their own colors. Either way is possible. Just depends on what you feel like. Yeah, Louis just adding more features where we haven't even got the game started yet. But yeah, that's something that's what kind of stuff that you can add, you know, as kind of polished stuff at the end. Like once the game all works, you can be like, oh, it'd be cool if players, you know, could customize their dice. When I've done games like this in the past on other platforms, for example, something that's come up is people with like color blindness might have a really hard time seeing certain dice color combinations. You know, if you've got dice that are red and black, that might be difficult for them to see. Maybe green dice are easier for them to work with. Maybe green dice with white pips are better than green dice with black pips, right? So if you want to add some accessibility features to it, then having individually user customizable colors can be a great way to do that. And it's fun for everyone else, but it's actually the difference between being able to play and not being able to play for somebody who has like a particular color blindness. And there's a bunch of different kinds of color blindness that affect people differently. So just giving them the choice of what colors do you want to see is a huge step in accessibility for people being able to play your game. So in addition to just being a nice aesthetic thing, just because like blue is my favorite color, I want to have blue on there, then you're actually allowing people to play your game who otherwise might not have been able to. So stuff like that's great to add. Real simple stuff to add on the client side later once you've got the basics in there, because all you're doing there is you're just doing a material swap, right? And this asset pack that I got with the dice actually came with a bunch of different materials to start off with, and of course you can make my own. So if we look in here, there is you know, it came with blue, red, white, and then scratched up versions. I went with the scratched up versions because it's like aesthetic to ship captain and crew. If you're playing on a pirate ship, you probably don't have the shiniest of dice. But, you know, if I wanted to, I could come in here and just, you know, drop a blue material on it. So that would just be something.
Are the numbers actual geometry, or is that a normal map?
I haven't looked at it that closely. I would expect they are a normal map rather than actually. Yeah, it looks like yeah, it's got a normal map on it to make which is obviously the smart way to do it.
Yeah,
For
that's
performance
how I was
reasons.
thinking. If we needed them made, that's how I was thinking of doing it. But,
Yeah, so you can see that it looks like it's got some depth to it, but they're actually just completely flat faces with normal maps and such on them. So they're just PBR dice. They're relatively low poly. because
Yep.
dice are mostly just rounded cubes. But yeah, so
Yeah, plus sticking a little circle in there that's indented, it would be extremely hard and need a ton of geometry just to
yeah,
put a
it
little.
adds, especially especially if it's like a bowl shaped instead of just like a cylindrical indent.
Yeah,
You take dice that are like dozens of vertices and turn them into thousands of vertices
yeah.
if you want to actually model the individual pips. And while that's kind of cool, nobody's ever going to notice
Right.
um,
And I'm
because
certainly not going to
yeah,
do.
nobody's ever going to look at them that closely. So you're just making a bunch of geometry that nobody's ever going to see. Like Hinckley said, the correct way to do that is you can model the geometry and then bake it into the normal map and then put that normal map on a version of the dice that just has flat
I
faces.
I've actually got a plugin for Blender called PBR Painter that I can make alphas, so I can just make black and white pictures of those dice thing, and use a layer to do vertex displacement, and then save it out as a
Yeah,
normal map
basically the
that
same
way.
thing.
So it's really easy. Yeah,
Yeah, basically the same thing. Like what Hinckley's talking about is you would model the die with flat faces first and then unwrap those flat faces, right? Get it all set up, and then you could duplicate it, and then add more detail to the copy, and then bake the copy down into
yeah,
a normal map that then gets applied back on the simpler model.
yeah,
And that way, it looks like the better version, but it's
yeah.
1/100th of the vertices, and obviously you have a much better performance that way.
That is the ultimate technique. Everybody should learn that technique, actually. A lot of stuff will actually help you do it in Blender as well. There's a program called Simple Bake add-on that
Yeah,
will bake low to high poly, which is
yeah,
quite handy.
it's an important part of learning to make good video game assets
Yeah,
is that most video game assets are tricks, right? Most of what you think you see as geometry isn't in a well done video game. It's indistinguishable from real geometry if it's been done well, but it isn't real geometry, especially for fine details. If you want to add filigree carvings to something, insane amount of vertices to add like all those curves and loops and indentations and bevels and things like that. Or you can bake it as a normal map and nobody can tell the difference anyway, but it doesn't take any polys at all. So yeah, it's an important part of being a good video game artist if you're making content for a video game based platform. And we're using a video game engine, so all those same techniques apply. All right, I'm going to go ahead and stop recording then. Thank you everyone for coming and have a lovely weekend.